So we're going to start section 3.5 in this video. We are going to be talking about a lot actually in this section. We're going to be talking about different equations, different forms of equations of lines. Excuse me. Included in that at some point when we get to slope-intercept, that will give us kind of another technique to graph a line. But in this video, we're going to start with just looking at the standard form of a line. So the standard form of a line is just the x term plus the y term equals the constant on the other side. Now, this is fine. I mean, for example, suppose I have these equations. Suppose I have negative x plus 2y equals negative 2, and 2x minus 4y equals negative 4. There's two examples of equations in standard form, an x term, a y term, and then a constant. One thing that's kind of interesting about these is they aren't necessarily unique. You could multiply both sides through by a constant or divide by a constant, and they'd still be in standard form. So the a, b, and c aren't necessarily unique. So the first question here was, what form are these equations in? And so, we just said these are in standard form. Now suppose we were asked to put them into slope-intercept form. That is our second form of the line that you see up above. This one's a little nicer, I think, for a couple of reasons. Number one, if you're ever using a graphing calculator, this is the form that you will need to have it entered in your graphing calculator, at least in terms of it needs to be isolated for y. Also, it's unique. Once you get it into slope-intercept, it is the m and the b. There's only one slope-intercept form. Also, the m and the b, while being numbers, have particular meaning that the a, b, and the c just don't have in standard form. So the m is the slope, and the b number, including whatever its sign would be here, positive or negative, the b is the y-intercept of the line. And that, if you look at it, shouldn't be too shocking. Let's think for a second, if you were to sub in 0 for x in this equation, what would you have? You would have y equals 0 plus b, so you get back b for y. So b is going to be the y-intercept. So that's what we want to do in part B down here. We want to take each of these equations and put them into slope-intercept. So this will be something we'll be doing quite a bit. Slope-intercept form is often a preferred form of a final answer. Again, for many reasons, one of which being it's unique, another of which being you can identify the slope and the y-intercept. So the first thing you'll always do, and this is what we talked about back in the section where we were solving formulas in chapter 2, maybe 2.5, solving formulas for specified variables. So the first thing you would do would be to move the x term to the other side. So in this case, we would be adding the x to the other side. So we would have 2y equals the x minus 2. And then in this case, the last step, 2 is being multiplied by y, so we do the opposite and we divide by 2. And so now on the left-hand side, we have y. But now we do have to get this into the x term and then the constant. So what we have to do is we have to know to take whatever's in the denominator here, and you have to divide it by both terms in the numerator. You don't just get to reduce the 2. So in the first term, this is going to look like x, and I'll even write this way initially, over 2. In the second term, minus 2 over 2, and of course that's going to be 1, but I'll just write it out this way, at least for the first time. And now we would want to reduce, of course, where we can, and also that first term. We really want it to be the m, the number, and then times the x. So we want to recognize that this x is really like a 1x. So we can write that first term, which you'll start to do without even having to think about it too much. We're going to write that as 1/2 times x. So you can bring that, and the reason that works is, x is the same thing as x over 1, and then, multiply numerators and multiply denominators, and that's equal to x over 2. So we get to just kind of slide that x out in front there. and then minus the 2 over 2, that's minus 1. So there's the slope-intercept form. That, of course, means the slope of this line is 1/2. So we're asked to identify the slope and the y-intercept. And then the y-intercept is this constant term of -1, which sometimes they may just want you to type it in or answer it just -1. You know me, I tend to like the intercepts to be thought of as ordered pairs. So a y-intercept is always when the x-coordinate is 0, so 0, -1. Let's do the same thing on the second equation. Now that we went through it in all its detail, maybe this one will go a little quicker. So first we move the x term over, so we would subtract the 2x from both sides. And so now we're going to have a -4y equals -2x minus 4. And then to solve for the y, we need to divide by its coefficient of -4. And then we have to be careful because we don't just get to reduce the -4s. We have to know to divide each term in the numerator by that denominator of -4. So I'll write it out, -2 over -4 times the x on that first term. And the second term is the -4 divided by the -4. Now we definitely want to reduce. Including negative divided by negative is positive in that first term. And the 2/4 does reduce to 1/2. And in the second term, we do want to see the negative over negative is positive. And of course, that just reduces to 1. So the slope of this line is also 1/2, the coefficient of the x. And the y-intercept of this line is +1, or again, as I like to see them, an ordered pair 0, 1. Now, the last question here, the second question I should say, is are the lines parallel, perpendicular, or neither? So first of all, let's just observe that these are different lines. One has a slope of 1 and one has a slope of -1. So they're, I'm sorry, not slopes. Y-intercepts. One has a y-intercept of 1, one has a y-intercept of -1. So they're different lines, but they do have the same slope. So these two lines are definitely parallel. That's supposed to be an A. So these are parallel lines, and of course the reason here is because from the last section their slopes are equal. All right, now the last little piece to working with this slope-intercept form that we're going to really build on here is going to be using this slope-intercept form and everything we've talked about before to just kind of talk about a new technique to graph a line. So here's what we know. Okay, we know that the slope of the first line here, so we have y equals 1/2 x minus 1. So let's say that this is my first line right here. So y equals 1/2 x minus 1. So its y-intercept, it crosses the y-axis here at -1. And now think about what we know about slope. For either of these lines, what we know about a slope, and we did this in the last section with slope, is it is rise over run. So from any point on the line, I can go up 1 and to the right 2. So from my y-intercept of -1, I'm going to go up 1 and to the right 2. And I could continue to go up 1 and to the right 2. That's kind of the nice thing about slope, is even without a ruler, and sometimes quite honestly even better than a ruler, is extending the slope in both directions. And so this is my line, the first line, which is y equals 1/2 x. So this is y equals 1/2 x minus 1. All right, now let's take a look at the line and graphing the line y equals a half x plus 1. Its y-intercept, it crosses the y-axis up here at positive 1, but its slope is still up 1 over 2. So again, from that y-intercept and from any point on that line, you can go up 1 over 2, or, oops, I just made a mistake on that one. Or if you're going to the left, it's down 1 and left 2. And so this is the equation of the second line. So this is the equation of the line y equals a half x plus 1. So here's the thing. What we've really developed is a technique to graph lines using this slope-intercept form. That's what we're going to talk about next time. We'll generalize the process. And then eventually we'll get into, I know I haven't mentioned anything yet about that last form of the line. So as we kind of compare these three forms, I would say the standard form is it's an okay form. There's nothing wrong with it. The slope-intercept, that's a real nice form of the line, and I would say it's particularly good for graphing, right? We just discovered that it's really useful for graphing. It also gives us a unique solution. This third form of the line, what is it going to be good for? Well, it is going to be good for, or let's not even say good for, we'll say it gets used whenever we want to find an equation of a line. So that's why sometimes this is called the point slope formula, because it's a formula to find an equation of a line. So those are kind of our three forms there. But next time when we come back, we're going to continue what we just did in Part D. We're going to formalize that process, kind of have the steps written out, and look at a couple more examples there.